For nearly half a century, it drifted silently through the infinite void, a solitary ambassador of humanity, venturing farther than any creation of our hands had ever gone. Launched in 1977, this spacecraft, a marvel of engineering from an era of bell-bottoms and typewriters, was never meant to last this long. Yet against all odds, it has endured, floating 15 billion miles from Earth, in a realm where the sun's light is a faint whisper, and the stars are the only companions. And then, in a moment that shocked the world, it did the impossible. It phoned home. Not with its primary system, not with the tools it had relied on for decades, but with a backup transmitter, dormant since 1981. A piece of equipment so obsolete it was considered a relic. This wasn't just a signal. It was a cry from the edge of the cosmos, a pulse from a machine that refuses to die. What caused this miraculous event? How did engineers respond to a spacecraft that defied every expectation? And what does this mean for the future of our reach into the stars? The answers are nothing short of breathtaking, a story that will leave you questioning what's possible and inspire you to look up at the night sky with wonder. In October 2024, a routine command was sent to the spacecraft, a simple instruction to activate a heater to protect its delicate instruments from the frigid temperatures of deep space. It was a procedure done countless times before, a small nudge to keep the aging machine alive. But this time, something went wrong. The spacecraft's fault protection system, a built-in safeguard designed to shield it from harm, misread the command as a threat. In an instant, it shut down its primary X-band transmitter, the lifeline that had carried its voice to Earth for decades. Silence fell. For the first time in years, the connection to this interstellar pioneer was severed, and for a moment, it seemed as though humanity's furthest emissary had been lost forever. Engineers at the Deep Space Network, a global array of massive radio antennas, stared at their screens in disbelief. The signal was gone. The spacecraft, 15 billion miles away, was mute. But then, something extraordinary happened, something no one could have predicted. Without any human intervention, the spacecraft made a choice. It switched to a secondary S-band transmitter, a system so old it hadn't been used since the Reagan administration. This backup, weaker and slower than its modern counterpart, was never meant to carry a signal across such an unimaginable distance. Yet from the cold, dark abyss, a faint whisper emerged, a ghostly message, traveling for nearly 23 hours to reach Earth. It was alive. It was calling home. The challenge of catching this signal was monumental. The S-band transmitter was a shadow of the primary system, its signal so weak it was nearly drowned out by the cosmic noise of the universe. Every bit of data took almost a full day to arrive, and another day for a response to travel back. The margin for error was razor-thin. One wrong move, one miscalculated command, and the spacecraft could shut down entirely, lost forever in the void. Engineers worked around the clock, their hearts pounding as they fine-tuned the massive dishes of the Deep Space Network. They adjusted frequencies with the precision of surgeons, coaxing the faint signal out of the static. Days passed in a haze of calculations and sleepless nights, each moment heavy with the weight of history. And then, on October 24th, 2024, the breakthrough came. The signal stabilized. The connection was restored. The spacecraft, thought to be on its final breath, had roared back to life, using a system no one believed could still function. For the teams on the ground, it was more than a technical victory. It was a moment of pure, unfiltered awe. A machine built by human hands, launched when disco ruled the airwaves, had just reminded the world that it was still out there, still fighting, still carrying humanity's dreams into the stars. This wasn't the first time the spacecraft had defied the odds. When it launched in 1977, its mission was modest: study Jupiter and Saturn, snap a few pictures, and gather data on the gas giants. No one expected it to become a legend. But in 1979, it rewrote the history books with its flyby of Jupiter. Its cameras captured swirling storms the size of Earth, turbulent clouds in shades of red and orange, and the first close-up images of the planet's moons. One of those moons, Io, stunned scientists with evidence of active volcanoes spewing plumes into space, the first time such activity had ever been seen beyond Earth. The discoveries didn't stop there. In 1980, the spacecraft soared past Saturn, revealing the intricate beauty of its rings. Thousands of delicate bands woven together like cosmic lace. It even discovered new rings, including the faint, mysterious G-ring, a feature no one knew existed. But the spacecraft's ambition stretched beyond its original goals. After Saturn, it didn't slow down. It kept going, propelled by a slingshot of gravity and the audacity of its creators, until it left the solar system entirely. In 2012, it crossed the heliopause, the boundary where the sun's influence fades and the interstellar medium begins. It became the first human-made object to enter this uncharted territory, a pioneer in a realm no telescope could fully explore. And even then, it didn't stop. It kept sending data, measurements of cosmic rays, magnetic fields, and the strange ethereal plasma that fills the space between stars. Each transmission was a gift, a glimpse into a part of the universe no one had ever touched. This latest chapter, though, is something different. The reactivation of the S-band transmitter isn't just a technical fluke. It's a testament to the genius of redundancy. When the spacecraft was built, engineers included backup systems, fail-safes for a mission they knew would push the limits of technology. Those systems, forgotten for decades, have now proven their worth. The fact that a transmitter silent since 1981 could spring to life and carry a signal across 15 billion miles is a reminder that no detail is too small when you're reaching for the stars. But it's more than that. It's a lesson in autonomy. For years, the spacecraft has operated largely on its own, detecting problems and correcting them without real-time guidance from Earth. Every command takes nearly 2 days to complete a round trip, so the machine must think for itself, making decisions in the loneliness of deep space. This event shows how far we've come in building systems that can endure, adapt, and survive in environments we can barely imagine. And yet, for all the talk of circuits and signals, there's something deeply human at the heart of this story. The spacecraft isn't just a collection of metal and wires. It carries a piece of us, a message etched in gold, a record of who we are and what we dream. Mounted on the spacecraft is the Golden Record, a 12-inch gold-plated disc that holds humanity's voice. It's a time capsule, a snapshot of Earth in 1977, created to tell the story of our world to anyone or anything that might find it. The record contains greetings in 55 languages, from ancient Akkadian to modern English, each one a whisper of connection across the cosmos. It holds music, from the intricate melodies of Bach to the raw energy of Chuck Berry, from traditional Navajo chants to the haunting sounds of a Japanese shakuhachi flute. There are natural sounds too, the crash of ocean waves, the song of a nightingale, the rumble of thunder, the soft coo of a baby. There's laughter, a heartbeat, the sound of a kiss. It's a portrait of life, of joy, of struggle, of everything that makes us human. And it's hurtling through space at 38,000 miles per hour, protected by a spacecraft that just proved it's not ready to give up. When that faint S-band signal reached Earth, it wasn't just data. It was a reminder that this message, this piece of our soul, is still out there, still traveling, still waiting to be heard. For those who worked on the mission, for those who watched from afar, it was a moment that brought tears to the eyes. A machine from the era of cassette tapes had reached across time and space to say, "I'm still here. Your story is still alive." The emotional weight of this moment can't be overstated. In mission control rooms and science labs around the world, people held their breath as the signal was confirmed. For some, it was a professional triumph, the culmination of years of expertise and dedication. For others, it was personal. Many of the engineers who built the spacecraft are retired now, their hair grey, their memories of the 1970s faded. Some have passed away, their contributions living on in the machine they sent to the stars. But for those still watching, still listening, this was a reunion. The spacecraft was a piece of their youth, a dream they poured their hearts into when the world was different. To hear its voice again after so long was like hearing from an old friend. Social media exploded with reactions, from astronomers sharing technical breakdowns to everyday people posting messages of awe and inspiration. This is why we explore, one post read. This is what it means to be human. Another simply said, "Thank you, Voyager, for reminding us to keep looking up." In an age of fleeting trends and disposable technology, the spacecraft's endurance struck a chord. It's a relic of a time when things were built to last, when a mission wasn't just about the present, but about the future, about legacy, about forever. But this story isn't just about nostalgia. The spacecraft's continued operation has real, tangible implications for science. Even now, in the vast emptiness of interstellar space, it's collecting data that reshapes our understanding of the universe. Its instruments measure cosmic rays, high-energy particles that zip through the galaxy, offering clues about the processes that drive stars and black holes. It tracks the density and temperature of the interstellar medium, the thin soup of particles that fills the space between systems. It maps magnetic fields, revealing the invisible forces that shape our galaxy. These aren't abstract numbers. They're pieces of a puzzle, insights into the structure of the Milky Way and the boundaries of our solar system. Every bit of data is a treasure, sent from a place no other machine has ever reached. And because the spacecraft is still talking, scientists are asking bold new questions. Could other dormant systems be reactivated? Could the mission, already decades beyond its original scope, uncover new secrets? There's even talk of recalibrating its instruments to study space weather, the streams of charged particles that can disrupt satellites and threaten astronauts. The spacecraft, once thought to be nearing the end, might still have surprises in store. The technical details of this event are staggering. The S-band transmitter, for one, is a marvel of resilience. Designed in an era before smartphones, before the internet, it was built to handle short-range communications, not to shout across billions of miles. Its power output is a fraction of the X-band system, and its data rate is glacially slow by modern standards. Yet, It worked. The signal, traveling at the speed of light, took 22 hours and 48 minutes to reach Earth, crossing a distance so vast it's hard to comprehend. To put it in perspective, light from the sun takes just 8 minutes to reach us. The spacecraft is 1,800 times farther away than that, so far that even our most powerful telescopes can't see it. The Deep Space Network, with its 230-foot-wide antennas in California, Spain, and Australia, had to be recalibrated on the fly to lock onto the signal. Engineers used techniques that didn't exist when the spacecraft was launched, combining modern software with 1970s hardware to pull off the impossible. It's a reminder that exploration isn't just about the machines we send. It's about the ingenuity we bring to the table, the willingness to adapt, to innovate, to never give up. Beyond the science and the engineering, there's something deeper at play. The spacecraft is a symbol, a beacon in the darkness. It's the furthest thing we've ever built. A tiny speck of metal and ambition drifting in a sea of stars. It's alone in a way nothing else is. Untouched by gravity, unbothered by the chaos of human life. And yet, it connects us. When it phoned home, it wasn't just talking to antennas, it was talking to us, to every person who's ever looked up and wondered what's out there. It's a reminder that we're capable of greatness, that we can build things that outlast us, that carry our hopes beyond the horizon. The Golden Record, with its sounds and images, is a love letter to the universe, a declaration that we exist, that we feel, that we dream. And the fact that it's still out there, still protected by a machine that refuses to quit, is a kind of miracle. It's a spark of hope in a world that often feels fractured and fleeting. If a spacecraft can survive 48 years of silence and still find its voice, what can we do? What can we build? What can we dream? This moment also forces us to confront big questions about the future. The spacecraft won't last forever. Its power supply, a set of radioisotope thermoelectric generators, is slowly decaying, losing a few watts every year. By the late 2020s, it may no longer have enough energy to run its instruments. When that day comes, it will drift on, a silent messenger carrying the golden record into eternity. But until then, every signal is a gift, every byte of data a victory. Scientists are already planning how to maximize its remaining years, prioritizing which instruments to keep active, which measurements to prioritize. There's a sense of urgency, but also gratitude. The spacecraft has already given us so much. Images of distant worlds, data from beyond the solar system, a story of resilience that will inspire generations. And now, with this unexpected revival, it's giving us one more chapter, one more chance to listen to its voice. The implications of this event stretch beyond the spacecraft itself. It's a wake-up call for how we approach exploration. The redundancy that saved the mission, those backup systems built in the 1970s, shows the value of planning for the long term. In an era where technology moves at breakneck speed, where phones are obsolete in a year, the spacecraft's longevity is a challenge. Can we still build things that endure? Can we create missions that outlive their creators, that speak to our descendants? The autonomy of the spacecraft, its ability to act without human guidance, also points to the future. As we send probes to Mars, to Europa, to the stars, they'll need to think for themselves, to navigate dangers we can't predict. And then there's the human side. This event has reignited public interest in space, reminding people that exploration isn't just about equations and budgets. It's about wonder, about pushing the boundaries of what's possible. Posts on social media, trending hashtags, and viral videos show a world hungry for stories of triumph, for proof that we can still do big things. The spacecraft's story is also a mirror. It reflects who we were when we launched it, a species bold enough to send a message to the stars, naive enough to believe someone might hear it. In 1977, the world was messy, divided by wars and politics, but it was also full of dreamers. The Golden Record was a product of that optimism, a belief that even in our imperfection, we had something worth sharing. Today, the world is different, but the spacecraft hasn't changed. It's still out there, carrying that same message, that same hope. When it phoned home, it was like a letter from the past, a reminder of what we're capable of when we dare to dream big. And it's a challenge to the present. Are we still those dreamers? Are we still willing to take risks, to build things that matter, to reach for the impossible? The spacecraft doesn't care about our doubts or our distractions. It just keeps going, a lighthouse in the void, shining a light back at us. As the news of this event spread, it sparked conversations around the globe. People shared stories of how the mission inspired them as kids, how it shaped their careers, their passions, their sense of what's possible. Teachers used it to spark curiosity in classrooms, showing students that science isn't just about textbooks, it's about adventure, about chasing the unknown. Artists created tributes, from paintings of the spacecraft against a starry sky to songs about its lonely journey. Scientists, meanwhile, dug into the data, eager to see what new insights it might reveal. The signal itself became a kind of metaphor, a faint but persistent voice. In a noisy world, proof that even the smallest whisper can carry meaning. For those who worked on the mission, it was a moment of closure and continuation, a chance to celebrate a legacy while looking forward to what's next. The spacecraft, in its quiet way, had brought people together, bridging generations, continents, and perspectives. There's something poetic about the timing of this event. In a world obsessed with the next big thing, the spacecraft is a reminder of the power of the past. It's a product of a time when exploration was a shared dream, when nations competed not just for power, but for knowledge. Its technology is ancient by today's standards, its computers have less memory than a modern calculator, but its purpose is timeless. It was built to explore, to discover, to endure, and it's still doing that against all odds. The S-band transmitter, silent for 43 years, is a symbol of that endurance, a spark of life in a machine that should have faded long ago. When it switched on, it wasn't just a technical fix, it was a statement. The spacecraft is still here, humanity is still here, our curiosity, our ambition, our need to explore, it's all still here, encoded in a signal from the edge of the universe. Looking ahead, the spacecraft's story is far from over. Scientists are optimistic that it can keep sending data for a few more years, maybe longer if they can stretch its power supply. There's talk of new experiments, of tweaking its instruments to capture data in ways no one planned in 1977. The interstellar medium is still largely a mystery, and every measurement is a step toward understanding it. Beyond the science, though, the spacecraft is a catalyst for bigger dreams. It's proof that we can send machines, and maybe one day people, to places we can't yet imagine. Future missions, from probes to distant moons to telescopes peering into the early universe, will build on its legacy. The engineers who saved the mission, who caught that faint signal, are already sharing their knowledge, training the next generation to listen for whispers from the stars. And the golden record, that golden disk of sounds and dreams, will keep traveling long after the spacecraft's power runs out, perhaps for billions of years, until it finds a new home or fades into the cosmic dust. In the end, this isn't just a story about a spacecraft. It's a story about us, about what we can do when we work together, when we dare to dream, when we refuse to give up. The spacecraft is a piece of humanity, a fragment of our curiosity sent to wander the stars. When it phoned home, it wasn't just a machine talking, it was us, reaching out across the void, proving that we're still here, still searching, still alive. It's a reminder that exploration isn't just about finding new worlds. It's about finding ourselves, about remembering who we are and who we can be. So as you read this, think about what that signal means to you. Is it a call to adventure? A spark of inspiration? A reminder to keep pushing forward? Whatever it is, let it stay with you. Share this story with someone who believes in the impossible. Talk about it. Dream about it. Let it remind you that somewhere out there, 15 billion miles away, a piece of us is still traveling, still speaking, still carrying our voice to the stars.